Cool. So yo, what's up, everybody? How's it going? Hopefully, you guys are having a great day. Just making sure things are live. Can you give me a thumbs up if you can hear me? That makes my life easy. So, and I'll unpin this. Okay, now it should be good, right? And hopefully, you guys can hear me. Right? Cool. Sweet. Okay, so how do you hope, everybody? Yesterday we completed our OVAPs top 10, and today we have something more interesting coming through. As requested, and as you remember, if you guys remember, yesterday we were chatting with Mr. Stimulus, and he mentioned that he's doing WireShark, right? So I thought a great tool to work towards, and because somebody in the community is already doing it, something you all can learn from everywhere it's used. So we'll start with that today, and we'll cover the WireShark basics. It's very useful. A lot of people love to use it, and so that's what we are doing. So without further ado, let's do that, and let me make my webcam a bit smaller this time so it's easy for you guys to view all the things that will be coming through. One sec. Okay. Okay, that should be good. Cool. Transition. Nice. I look weird today, but that's pretty good. Now let's get started with Wireshark 101 Wireshark module, right? TryHackMe, this is the module link. I can just send it with you guys here. So Wireshark is the industry standard tool for network protocol analysis and is essential in any kind of traffic investigation. Basically, the traffic they are talking about is like the network traffic, just in case if you guys don't know, right? And hopefully you guys can hear me. Can you give me a thumbs up if you can hear me? Hopefully you can, right? Okay. This module will cover need to know functionalities of the Wireshark for any security analyst, traffic sniffing, dissection, and navigation, packet filtering and analysis, and traffic analysis. You'll learn how to use Wireshark when investigating live and captured traffic and identify anomalies, threats, and attacks. By the end of the module, you will master your Wireshark skills and will be able to investigate complex network cases and create an IOC list and actionable results with the Wireshark. So I don't know what IOC is actually. Maybe let's see quickly. Indicator of compromise. Oh, okay. So how things went compromise, how things were compromised, what happened, and all those stuff. Okay, cool. If we can do that, that would be nice. So Wireshark, the basic, learn the basics of Wireshark and how to analyze protocols and PCAPs. What are modules? Basically, they're divided into these things. So let's get started with this walkthrough. Wireshark, the basics. Learn the basics of Wireshark and how to analyze protocols and PCAPs. And before we getting started, I'll just start my virtual box so we are not stuck during that time. So it's a 60-minute one, and today I'm just busy, so I'll try to complete this as fast as possible. And if you have any questions, feel free to let me know. Mm, okay, lengthwise we good. So Wireshark is an open source, cross-platform network packet analyzer tool capable of sniffing, investigating live traffic and inspecting packets captured. So they're captured, I think, in PCAP format. Let's see. Packet capture, PCAP, is a networking practice involving the interception of data packets traveling over a network. Once the packets are captured, they are stored by IT teams for future analysis. The investigation of these packets allow IT teams to identify issues and solve network problems, investigating daily operations. And one thing I will tell you this, I was looking through some of the stuff. So there are 3 modules, but also there are a couple of great CTFs, and also a couple of great challenges out online or on TryHackMe. So we will do that as well. So it is commonly used as one of the best packet analysis tools. In this room, we will look at the basics of WireShark and use it to perform fundamental packet analysis. Start machine button. So I'll go here. Probably we don't need one today. That's nice. A new virtual. Okay. The machine will start a split screen view. If it is not visible, use the blue show split view button at the top of the page. Okay. No, and if you guys are wondering, this is the one, show split view. I always like to just open it in a new one. Failed. Try again. Interesting, eh? Hey, come on, come on, come on, come on. Okay, it's here. That's great. Cool. Okay, so note, a virtual machine is attached to this room. You don't need to SSH or RDP. The room provides a split view feature. We suggest completing the networking module before starting this room. Okay, so what is the networking module? Networking module, okay. The WireShark basics, this is part of it, TCP term and map. We can start with this. We can also take care of this once we're done with the WireShark basics. But let's just go ahead anyways. Now we are here though. There are two capture files given in the virtual machine. You can use the HTTP1 PCAP PCAP-NG or PNG, I guess, file to simulate the actions shown in the screenshot. Please note that you need to use the exercise PCAP-PNG file to answer the questions. Okay. Which file is used to simulate the screenshots? Okay. Okay, let's see. So we have 1, 2. So there are two capture files in the VM. You can use h1 file to simulate the action shown in the screenshots. Please note you need to use this file to answer the question. So this is the one with the screenshot. And this is for exercise. Nothing much here, I give in this one, in this task at least. So task 2, tool overview. Use cases. WireShark is one of the most potent traffic analyzer tool available in the wild. So very, very big. And that's why I was pretty excited about this one, because this tool is used everywhere. From beginners to advanced people, everybody loves this tool and everybody uses this. There are, and if you are going into networking, like a network admin and all those stuff, this is really helpful to like create stuff and like just work through those. So there are different purposes for this, its use. Detecting and troubleshooting network problems such as network load failure points and congestions. Detecting security anomalies such as rogue hosts, abnormal port usage, and suspicious traffic. Investigating and learning protocol details such as response codes and payload data. Note, WireShark is an intrusion detection system, IDS. It only allows analysts to discover and investigate the packets in depth. It also doesn't modify packets, it reads them. So important thing to know, it doesn't modify, it just reads them. Hence, detecting any anomaly or network problem highly relies on the analyst's knowledge and investigation skills. So basically, it provides you like a good GUI with like all the things captured, and filters you can add, and all your skills are then involved to help you understand what's going on. That's basically, I will say, the basically it part of it. That's what it's looking for, and that's how things work. Wireshark GUI, GUI and data, right? Wireshark GUI, graphical user interface, the things you see, opens with a single all-in-one page, which helps users investigate the traffic in multiple ways. At first glance, 5 sections stands out. So let's open that on the side too. WireShark here. What is this? Software update. Okay. So this is the GUI, the starting one, right? Let's see what they are talking about. Make sure. Okay. So the toolbar. The main toolbar contains multiple menus and shortcuts for packet sniffing and processing, including filtering, sorting, summarizing, exporting, and merging. So these menus, I guess, sorting and all those, apply the filter and all those other stuff, goody good stuff. This is your toolbar. Whole tool. Display filter bar, the main query and filtering sections of this one. Let me increase the size actually, so it's easier for you guys. Preferences, probably here you'll see font and color. So font, I want at least size to be, okay, I think this one will do the job. Did it make a difference? I don't think so. There must be other fonts required. Other places like fonts is required. Appearance, language setting, columns, font, 18, capture, filter. Okay, protocols. No, that's not one. Advanced. Okay. This is like almost the same for VR, right? Stimulus. Howdy do. Howdy do. How's it going? We are here. The WireShark, right? Must be pretty excited. I'm very excited. When you mentioned WireShark, I was like, this is some tool like I always wanted to learn. So I'm pretty excited about it. How was your day so far though? That's my brother, ladies and gentlemen. That's my brother right there. My big bro. Let's see one thing. The credentials do help. WireShark. I want to increase. Is this like good font? Can you let me know? Woke up at 3 a.m., couldn't sleep, but at least now there's a good reason to be up. Thank you, man. Thank you. Yeah. No, 100%. It's great to have you. And best way, like, I feel like the best thing to sleep is like just do some push ups or read a book. That helps me to sleep. I understand what you are going, like, probably not a lot because you mentioned you are in paramedics. There's so much more to it. But like one thing I do is just read the book. Helps me to sleep better for some reason. Maybe like that dopamine detox thing actually helps me, I guess. But have you like how to change these system default color style, blah blah blah? Okay. I think is the font good though? Like, is this? Do you want me to increase the font a bit more? Are you able to see it? Increase. Oh, maybe that might be the system font. Appearances, fonts, and color. No, I can read it on my PC. Oh, okay, cool. That's good. That's good. I think like this might be like they're picking not exactly picking from the one settings I did because I did like edit preferences, appearance, fonts and stuff. So if I'm trying like something bigger, it should change here. It doesn't make any change. Oh, it's okay, I guess. I think one this is why like I love Linux because it's open source and stuff, but like everywhere you go, they have their own version of it. So it's really hard to find sometimes something. So maybe I can go graphics, interface, no, system tools, nope, screen reader, internet. The graphic. I guess all good. I guess today we probably won't be able to find all good. I guess what can we do? Preferences actually here. Personal. Nah, nothing. I'll make a note of it for you for later. Oh, thank you. Sounds good. Thank you. So let's just go over this, I guess then. So GUI, right? GUI, graphical user interface, basically the screen you guys see, right? This is the main screen. And now we have the toolbar, the top toolbar with things that are here, which contains like file, edit, making those things, right? And a couple of other stuff. Then we have the display main one, the display filter bar. This is the main one, I will say, because this is where all your filters, everything will go. Everything will go here. So majority of the time people are playing with this. When I do CETF challenges, this is where I'm playing all the time. Recent files, list of recently investigated files. You can recall listed files with a double click. So basically, I think captured random package generator, blah, blah, blah. Oh, here, open. These are the files. So HTTP1 and exercise file 1. Okay. Capture, filter, and interfaces. So that's the one I was looking at. Capture, basically, if you see here, like these lines on like I can show you on my Kali actually, that will give a better idea. So here we have WireShark. And this will be interesting to look at. So I don't have any other files, but on this, let's say Ethernet, and then there's this one. I can just start like interesting stuff for this to make it work. Close this guy. So if you see here, right, this is the interesting part. You see like the heartbeat come for Ethernet, tunnel, and any. This heartbeat type, like this, basically this activities show which one is like more has activities, which port or which tunnel or however you like to put it, where the activities are happening. So you can capture that specific one. So that's what is good. That I love WireShark. Like honestly, I love WireShark, and I'm super happy. Thank you so much for suggesting this. I'm super happy. I'm taking this. So capture filters and files. Essentially customizing a visual filter. So I didn't get essentially customizing a visual filter with activity. Visual filter. Oh yeah. Makes sense. Sorry, it took me a couple of seconds to hit my brain. Yeah, essentially giving you a visual look at the filter. Yes. And there are so many of these, so many good settings in this you can set up. I can close this because it's annoying me. Yeah. Then there is status bar. Tool status profile and numeric packet information. And good part is like they did a great job here. So is the ready to capture and all those status. Okay, let's go here. So in the red one is the toolbar, display filter, recent files, capture filter, and available sniffing interfaces. Interface, that's the right word. Status bar. Loading PCAP file. PCAP files are the ones with filters inside them, right? Sorry, packets inside them, packet files. The above picture shows WireShark's empty interface. The only available information is the recently processed HTTP1 PCAP file. Let's load that file and see WireShark's detailed packet presentation. Note that you can only use file menu, dragging and dropping the file, or double clicking on the file to load the PCAP file. So here we go. And I think, oh, this is not the one. Sorry. Here. So we have this, and we can go with the H3B one because that's for the things we are seeing. So here, the font is pretty big. Oh, that's good. Here we can see our HTTP PCAP file, right? And all the packets and everything. Let's go what it says. Packet details. So whenever we click packet bytes, I think we hardly use, not used a lot, because packet details are where the information is in human readable, much easier format. So this is the file name on top, pcap1. Then there is package list, all the packets that were happened. Packet details with the file name again on here. I guess I can do this. File name again here. Packet details. So whichever packet we have selected, like the first one in this case, all the details about various network layers. So Ethereum, Ethernet 1, ICP, Internet Protocol 1, level 3, level 4, TCP, IP, all those stuff. Bytes, we hardly use. There are sanitized information, but I have hardly used it. Maybe I haven't done much. So then it says about here other information, packets, total number of packets displayed that are being displayed, all the stuff. And yeah, I think that's it. So let's move to the next thing, what it says. Now we can see the processed file name, detailed number of packets, and packet details. Packet details are shown in 3 different panes, which allow us to discover them in different formats. Okay, that's great actually. Different formats, I love that. Packet list pane, summary of each packet source and destination address, protocol, and packet information. You can click on the list to choose a packet for further investigation. Once you select a packet, the details will appear in the other panels. So when we, let's say, select this one, HTTP download HTML, right? Hypertext transfer protocols, HTTP, TCP, like you see transition control protocol, IP, Internet Protocol, Ethereum. Frame is more, I think, like level 1. It reaches level 1, physical one. Here it's very hard to understand what's going on with the bytes and stuff. So you have to move here, which basically if you actually go on hypertext and click, this goes information, right? It's basically is converted. So that's why I hardly touch the byte ones. All the information are here. Okay. Packet, hopefully this makes sense, right? Able to understand and things, right? So packet details pane, detailed protocol breakdown of selected packet. Protocol breakdown of selected packet. Okay, so basically whichever packet we selected is breaking down all the protocols like hypertext. Like you will see there are 2 models, right? This is a good networking, I think 101 for a lot of people. So networking, right? A lot of time there's like, it's one of the 2 models are used, but they are kind of same. It's just how people put it, I will say. One has 5 layers, 5, and one has 7 layers. I don't understand why they haven't come up with a standard 1, 2, 3, 4, 5, 6, 7. I don't understand why they haven't come up with the just basically 1, but whatever. I like the 5 one because it's easier. So 1 is physical, which is your actual copper wires, optical fiber, all those. This is physical. Then comes the Ethernet one, where data is being transferred, right? Ethernet stuff. Physical is like basically the copper. Ethernet is more like, okay, data is being transferred, that Cat5 and all those. Then we have IP, right? That's how it is, right? OSI model. Not OSI. OSI, and what is the 5 one? Oh, TCP IP model, yeah. I like the TCP IP model. TCP IP model. And this is a good image, right? It shows the whole ideology. Open image in new tab. Let's go. So OSI model 7 layers and basically 5 in TCP. Network physical data link, which is our, I think this is where Ethernet and copper thing I was talking about. One sec. I keep on making this mistake. So physical, this one is your copper and Ethernet things are covered, right? networking layer and transportation layer. This is transportation. This is your TCP/IP stuff. This is what decides which computer in this world will get the packet that you are sending. So if you are, let's say, sending a Amazon packet or like a FedEx package, right? You put an address, your returning address, and the person you want to send to. That's done here. And how things will look. The application layer, or basically like the session layer, application layer, both have the same name, right? This is your hypertext HTTP protocol or FTP protocol, all those ones. So if we actually look at now the WireShark one, right? It's more like this work done, TCP IP layer ways. So let's look at that now. HTTP layer 5, TCP layer 4, layer 3 IP, layer 2, layer 1. So hopefully that makes sense why there are 5 and stuff. And a lot of time you technically don't always, you're just sending back and forth, like acknowledging. Whereas the get one is more like a user interface one, right? Hypertext. That's why you have 5 layers. But some of them, it's like setting up a connection between just computers, not showing anything to the user. So there is no presentation or application layer. When they talk about each layer adding header information, when it comes down to it, it is literally just a piece of that section data. Like, yes. So header information, right, is just like a extra data, or like, the necessary information about a packet. And that's what, yes. For example, let me explain to you how it works. It's way more easier. So let's say we have physical layer, right? Physical layer, because it is at the very core, is simple. So physical layer, like copper, whatever, is some bits and bytes, zeros and ones, right? It has a header value. I'll put some extra here. Just talking about like whatever information, this is its header. But now this bits and bytes are kind of basically compressed and put into this whole packet is now with extra information is put into Ethernet. And Ethernet has its own extra information plus a header of itself. Let me make it better. So this packet plus some extra information plus a header, Ethernet header, a layer 2 header. And this header is more about like the things like where it goes and how it is being transferred and a couple of extra stuff. So that's how it works. It's also, header also has so much more information. Specifically, if we are talking about header of, I think, TCP IP one, like the network 3 and network 4, those are very helpful because those are the one that can actually tell you if your like some packet is lost, right? Of the headers, but the header itself, if you were to isolate a header, is it just a few lines of code? It's few lines of information, yes. Not code, lines of information. Yeah. And give me 1 second. I'll be back in 1 second. And a great video to see, how I got into this, learning about this. This is social network video. Here, this one.
Okay, let's look at a sample problem. Suppose we're given a computer with a 16-bit virtual address and a page size of 256 bytes. The system uses one-level page tables that start at address hex 400. Maybe you want DMA on your 16-bit system. Who knows?
Very high level
The
thing.
first 2 pages are reserved for hardware flags.
So this one, right, he mentions about flags. There are 8 bits. So in these headers, there are bits, there are flags to help the information, the extra information, right? To help you understand whether something was lost, is it corrupted, or all those information, just those stuff. So hopefully that answers your question, like concept of header over the header itself. And so every layer has it. So you technically don't code it. It's already there in the system itself. So here, I think this is a great image. This one, application layer, whichever data, and it's like one computer goes to other, right? So data, this will add this TCP header, network layer will add IP address header, Ethernet will add its own header about checksums and all those stuff. Goes back and it's like goes back, bum, 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 bum. So hopefully that helps. And another great way to understand is, yeah, just like if you're delivering a package, right? You keep on putting, go forward with the packet details pane. We covered that, this one. Packet bytes pane, which I hardly touch, but this is what it is. Bytes one, right? I mentioned. Very hard, like it's hard to read, that's all. Coloring packets. Along with quick packet information, WireShark also colors packets in order of different conditions and protocols to spot anomalies and protocols in captures quickly. This explains why almost everything is green in the given screenshot. So here, this one, everything is green or blue, so things are fine, I guess. This glance at a packet information can help track down exactly what you are looking for during an analysis. You can create custom color rules to spot events of interest by using display filters, and we will cover them in the next room. Interesting. Now, let's focus on the defaults and understand how to view and use representative data details. So, Wireshark has two types of packet coloring methods: temporary rules that are only available during a program session, and permanent rules that are saved under the preferences file profile, okay, available for the next program session. So this is interesting. I think I have to play with this a bit more. You can use the right click menu or view coloring rules menu to create a permanent coloring rule. So that's R1. If we are setting up our own system, colorize packet list menu deactivates the coloring rules. Temporary packet coloring is done with right click menu or, excuse me, view conversation filter menu, which is covered in task 5. Colorize packet filter list menu deactivates the coloring rules. Okay. Temporary packet coloring is done with the right click or view colorization filter. So, okay, this is connecting again. The default permanent coloring is shown here. So if we go in view coloring paths, TCP, okay, with the packet name type of filter, it will do that. And time for packet sniffing. Sniffing is fun though. Sniffing is fun. You just want to go to a Tim Hortons and just start sniffing the packets, just for fun. I will say it's interesting to do those things, and I don't recommend it, but it's just fun. I can see myself just sitting one day tapping packets just for fun of learning those. Till this is getting, I don't know why it's taking time to connect. Add 1 hour. This was okay. This one actually stopped working. So that's why. I don't know why TryHackMe keeps on having these issues recently. This won't work. Okay, go here, open a new file, or new tab actually. So while this is coming up, I thought about how it would be fun to find ways to implement things I learn into real world. Might try hacking my own stuff once I know. Yeah, it's interesting. I think I can tell you, I can give you a quick thing, right? There is something, if you want to learn about this, Cisco Labs, I think that's the Cisco software for learning This is an interesting one you can set up. I think this is learning network. There is a one specific, and this is also like I can just put it in my wish list, man. Or wait, let me close this first. Let me put my wish list in no Obsidian. This is I think I can show you also on the weekend. We can do this. TryHackMe note WireShark or wish list actually wish list. Wish list or bucket list, maybe one of those two things. But what we can do is there is a Cisco software. You can it's a free one, and you can set up basically a whole lab in it, right? With like routers and stuff, and you can sniff packet as if you're actually sniffing a real live data to help you understand what's going on. Really beautiful tool. I forgot. I've seen it in some presentation. Software by Cisco to simulate lab. One thing I will say, sir, Simulus, if you are interested in these things, right? Go just look at some of the conferences. There are so many. Here's this one, CCNA training one. So you can just go through these and like you will learn so much just by going through the sessions. If there is any happening near you, you will learn that. That's how I learned. So Cisco Packet Tracer, that's the one. I can send this Cisco Packet Tracer. I just want to make sure it's the right. Yeah, it's on the netcard. Okay. So Cisco Packet Tracer, there are certain, I think, free ones, right? You can set up and you can set up your technically your whole lab for free in this. And it's a free tool. So amazing, great stuff, I will say. I have a look. Especially if you are doing the WireShark, we can actually like over the weekend, we can have a look at this as well. Just remind me, I forget things. So, but yeah, and this you can set up so many things. I attended this conference, or not conference, like basically a talk, and the person is able to set up like 3 computers, certain server. They are talking to each other. He's able to sniff the packets, and you can do those things. So amazing stuff. And you can do. You don't have to send so many. There's routers, packet level 4, and all those amazing stuff. Yeah, Wireshark here. So, DL protocols, but where were we? Oh no, we went far ahead in this. Uh, yeah, we were at coloring packet. So if we go to view and see stuff, come on, come on, come on. I have a lot of stuff this weekend actually. So I have to go do batches. I remember the Python thing we'll talk about in some AI, and maybe yeah, we can look at this. So can be done in one day, touching all those things. So if we go in view, coloring packets list, there's one. Coloring rules, conversation, coloring rules, that's our required. So if we go here, oh, I have to maybe cancel this first for a second. View, edit, preferences, increase the font so it's better view for you guys. Okay, hopefully this works. View and coloring rules. Nope, didn't work. All good. So bad TCP. I have no idea. ICMP errors, those I understand. ARP is like finding, using I think level 2 maybe. Protocol MAC addresses to find like, and that's what Ethernet use MAC addresses, that extra information, on header data. ARP is to find all the things in your current network. Try that actually. That's a interesting one to check. If you go, I don't want to do it on my system. But if you do ARP command, ARP-A, if I'm not wrong, it will give you a list of all the tools or all the devices connected in your system with the MAC addresses, and based on the MAC address, you can find what it is. For example, I did it for my Raspberry Pi because I didn't know if I sometimes forget its IP address, the local IP address. I'll do a ARPA information, gets me all the MAC addresses. Based on the MAC address, you can find what that device is, whether it's a Windows system, whether it's a Raspberry Pi, Google Home, Amazon Alexa, those things, or even iPhones or your phone. So interesting thing you can do really quickly at your home. Routing. So we have TCP. That's why those were in blue. HTTP is green. That's why they were in green, or SMB. Cool. So if we open HTTP 1, if we see blue, those are TCP, and other protocols are HTTP. So why it's not working? Okay, now it's working. So if you see blue HTTP here, DNS is blue. Interesting. So TCP is not. And these are bad, the black ones. Like the color black voice. Color black voice. I'm not racist. It's this is the color how they set it up. This is scary, man. Traffic sniffing. You can use the blue shark tool, basically this guy here, this one, this guy. So you can use the blue shark tool to start network sniffing, capturing traffic. The red button will stop the sniffing, and the green button will restart the sniffing process. The status bar will also provide the use sniffing interface and the number of collected packets. So here, let's say I want to, maybe I can start for my WireShark. So if I start with this one, I selected basically the interface I want to hit. I start capturing this. It gives me all the open VPN basically and stuff, things like that. So all those are like various things. Close that. Interesting thing. So start capturing the progress, gives me the live progress, number of packets sniffed, and all those things. Merge PCAP files. WireShark can also combine two PCAP files into a single one. You can use the file merge menu path to merge a PCAP file with the processed one. That's interesting. I never knew that was a thing. Have you what do you like? Let's say if we are doing a demo on the weekend, what something you would like me to do with the WireShark? When you choose the second file, WireShark will show the total number of packets in the selected file. So, okay. Once you click open, it will merge this existing PCAP file with the chosen one and create a new PCAP file. Note that you need to save the merge PCAP file before working on it. Okay, so if we see the image, merge, we get one HTTP2 as well, size with number of data records. Step 3, we see the difference. PCAP1, WireShark new PCAP file with displayed 43 become 526. Interesting. I never knew that was a thing. View file details. Knowing the file details is helpful, especially when working with multiple PCAP files. Sometimes you will need to know and recall the file details, file hash, capture time, capture file comments, interface, and networks. Okay, to identify the file, classify, and prioritize it, you can view the details by following statistic capture file properties by clicking PCAP icon located on the left button of the window. Okay, so statistic capture file properties. This is the whole properties shown. Copy to clipboard. Okay, that's actually pretty neat. This is like better. As you can see, hardware, operating system, application, interface, all those stuff. Nice. That's actually cool. Use the exercise PCAP file to answer the following questions. Read, okay, exercise 1. Read capture file comments. What is the flag? Okay. So let's do that. Exercise 1 PCAP file. Let it load. Oh, there are so many. There are 15, 16, 17, 20, 28, 29, 30, 32. These thousands, right? So many and so many packets. Almost 50,000 packets now. Taking its time. Nice. This will be an interesting one. Okay, so we have 58,620 packets. Interesting. And I know for this at least I can increase the font, so which is nice. Are you at least like help? Is this helpful? Like extra information I'm giving, is it like good? Like you guys want more like the thing I mentioned about the Cisco packet one, all those? Is that good or no? And this one is also interesting. No, edit. Come on, font color, size. Okay, now it's a good significance difference. So now let's look at that. Capture file comments. Properties. I like little off-topic stuff. Add context and you learn more. Yes, yes. And you can see here too, we have flag is TryHackMe Shark WireShark demo. Basically, capture file comments is same as like capture file properties, right? And in the comments is here file comments with the flag. Knowing the file details is helpful, essentially when working with multiple PCAP files. Sometimes you will need to know and recall the file details like file hash and okay, this is the same from there. I like how they did it. Copy. Is it for this one specifically? No. Right? So if I go statistic, capture file, it will be here too. Okay, it's everywhere. For every file they have it. Cool. So we'll do that. Total number of packets. So total number of packets, lads, you have to give this answer. I'm actually, it's hard for you guys to see because I'm in the way. I'll change myself. Now you have to tell me number of packets for this. I would love to hear the answer. I'm going to wait, no matter how long it takes. I want to hear from you what is the total number of packets we have in this file exercise.pcap png. It's all in the. It's all here. Legit, it's here. Love to hear. Let's put a timer. 5, 4, 3. I'm half here, half with the baby logo. Oh, sounds good. Sorry, sorry. Okay, all good. So, with anyone else not answering other than stimulus, so answer is actually on the top, bottom right, actually, here. So if you see, total number of packets displayed is always at the bottom, just like the exercise file open. I can actually remove myself. That will be better for this one. So I'll take away my face so it's easy to help. It's helpful to see. Bottom right, total number of packets in the whole file, which is 58,620. A lot of packets. But interestingly, it's not that big when you keep the system open for a couple of minutes. What is SHA-256 hash value of the capture file? So hash, right? So basically, the reason why all these packets are hashed, so a man in the middle attack doesn't happen, right? So give you example with the drawing. Let's say this is you, right? This is you. Basically, let's say censored hacker or stimulus, right? Or let's say panda. You are on your computer trying to access Google or trying to access the internet. Oh, I made a basketball instead of internet. All good. So trying to access the internet, right? Like Facebook. Make it better. Let me draw something better. So basically, over the internet, you are trying to access Facebook. Now, what you want is your connection to be secure. For example, you are adding password or username or other extra information, secret information. You don't want anyone else to see, right? That's why it's all the information sent is basically encrypted. If it is not encrypted, like the HTTP, this is the difference between HTTP and HTTPS. Encrypted and hashed, right? I think it's encrypted, not hashed. So here we are looking for hash, but encrypted, and you want that because if a man in the middle is there, man in the middle, some big companies like DigiNotar has been hacked because of it. You won't even know they are there, but they are sniffing all your packets. Like if you go to Tim Hortons, start sniffing, nobody will know. But so that doesn't happen. Things are hashed or encrypted. One of those two things. I accidentally closed my YouTube stuff. Hopefully this is still going on. Okay, awesome. Still going on. Hey, I got 2 concurrent viewers. That's amazing. Thank you. So for SHA 256, right, value in the capture file, when you go to this, again, I think properties, here we'll see all the information. You see hash of this packet. And there is SHA 256. There are different hashes. The one we are looking for is this specific one. Bingo. Let's go, baby. Okay, packet dissecting. This is probably, oh, this is a big one. Nice. This is probably the last one for today because I have a couple of things in the morning, like meetings and stuff. I have work, right? So let's do this one as the last one for today. Packet dissection. Tomorrow we'll complete this and move forward with more. Packet dissection is also known as a protocol dissection, which investigates packet details by decoding available protocols and fields. WireShark supports a long list of protocols from dissection, and you can also write your dissection script. You can also find more on dissection here. Okay. WireShark boundary. This file is how to for WireShark developers interested in writing or working on WireShark protocols dissectors. Oh, okay. This is cool. I'll just share this with you guys then. I might read it later tomorrow, maybe. Things didn't get copied, I guess. Copy. I love the fact that, like, basically at this point, YouTube is like, ad break ends. Oh, there's an ad break going on. Is there an ad break going on? Oh, I can't even snooze it. Shoot. Oh, I can snooze it. Sorry, lads. Ads are snoozed for next 5 minutes. Apologies if you saw an ad or ads are going on. Never mind, it started for some people. Is the ad, you guys seeing the ad right now? Maybe, maybe not. Because I know a couple of people are just subs at this point, so they won't see it. No, right? Like, okay. Hopefully you guys are not seeing the ad. Are you seeing it? Oh, okay, cool. Yeah, YouTube, I have no monetization right now, so it's good. You won't see anything on YouTube. But that's good. Thank you. So let's go here. Packet dissection. Basically, what it means is This is stimulus, the thing going back to like how header works, right? And all things. So basically dissecting the data and header extra information that was added and seeing what's going on in the very details of every single layer. That's what packet dissection is, or protocol dissection, basically, whichever protocol is doing. Different protocols have different data added when we are sending different headers data added. So we are going to look into that, which investigate packet details by decoding available protocols and fields. All this we looked here. So note, this session covers how WireShark uses OSI layer, basically the one with 7 layers, to break down packets and how to use these layers for analysis. It is expected that you already have background knowledge of the OSI model and how it works. So OSI model is the one with the 7 layers. I like TCP one much easier, but I think that's how they like it because it's much more better. It's more dissected. So OSI model, the one with 7 layers, application, presentation, session, all. Then there's transport, network. Network is more about your IP protocols. Transportation, TCP protocol or UDP, like your WhatsApp videos or like this one is technically TCP, I believe. Data link layer is your Ethernet and MAC address. Physical is your copper wire. Okay, so now let's see how they do it. Packet details. You can click on a packet in the packet list pane to open its details. Double click with while open details in new window. Double click will open details in a new window. Packet consists of 5 to 7 layers based on the OSI model. We'll go over all of them in the HTTP packet from a sample capture. This picture below shows viewing packet number 27. So we'll go at the one with number 27 written on it. So we have this like number, right? To 27. This one, and this is the HTTP one. Double click. Let's see what it gives us. Okay, we got a new window. It's like basically burp suite type level. So we got all our information. We have frame, which is basically, I believe, level 1. Ethernet with MAC address, right? This is the address. This is the MAC address. Source and destination is Xerox with like 000, all this. And this one is also a MAC address with FEFF20 and all those. Then we have internet with the IP source, IP address, and the destination one with IPv4 mentioned. There is IPv4 or IPv6. Then TCP with port mentioned, this source port, like from us is going as port 80, and for other person is receiving at 3371. Sequence, acknowledge all that information. To assemble TCP segments. That's interesting. So basically, the thing was divided into two, I believe. I'm not sure about this. HTTP protocol. So this is Google Ad Services.com. Gives all the URL information, HTTP URL, right? Request URI, policy reference. And it also talks about, I think, the encoding, right? The content type. It is a text, HTML, multimedia. Character set is ISO. You might see UTF-8, right? So all that and the file data information. This is good amount of information. And then this is line-based text data. So this is how the the HTML page will look with the head, style, and all that information. And the function. So this is like JavaScript functions also there. So this is what you see when you are using your computer. Let's go back here. What it says. Each time you click a detail, it displays the corresponding part in the packet bytes pane. Let's take a closer look view at the details pane. So we look at hypertext transfer protocols, which is HTTP protocol, like you see on the websites. We can see 7 dissect layers to the packet. Basically frame packet. Source, which is MAC address, as I mentioned. MAC address is hard coded. in your basic interface. Source IP, this can be spoofed. Protocol errors, application protocol, and application data. Like application protocol will be HTTP. Application data is the page itself. Below, we will go over the layers in more details. Okay. So layer one, frame. This will show what frame packet you are looking at and details specific to the physical layer of the OSI model. So when we looked at frame 27, excuse me, encapsulation type Ethernet 1, Ethernet basically, capture length, bytes. This is zeros and ones altogether. With time of arrival, interesting protocol in this is Ethernet, Ethernet type, IP, TCP, HTTP, data text. So it gives all the protocols headers that are there with TCP port and everything. This layer 2, which is the MAC one, right? And interestingly, I think there is MAC address lookup. So based on MAC address, or like this is not the same MAC as your MacBook Apple one. Both MAC addresses are different. One is your Apple. Other one is actually like basically how it is divided. There is one. There are 6 of these. And you will see, I will tell you why I covered this like this. So a MAC address, right? Whatever you have has this MAC address. Whatever if you're talking over a network, basically internet, I will say, this needs to have a MAC address, right? It needs that interface, network interface. And that's MAC address thing. Your network interface device, your NIC, will have a MAC address. First 6 bits, or like in the first 6 bytes, will help you understand what company it is. Second, this one is unique for that company. So together, let's say if was a, and this is how this complete thing is your MAC address. This is a company, like that's how I can tell, right? I was mentioning about whether it's a Google. Let's say if I know it's a Raspberry Pi I have at home, so I just have to look at the MAC address and see what first one is it. Is it talking about a Raspberry Pi, or is it talking about a Google Home? If it is Google, I know it is my Google Home. If it is Raspberry, I know it's my Raspberry Pi. But let's say if I have multiple Raspberry Pis, then it is hard because then I have to know their second part, which is unique for a company. And I don't know which one is what, basically. So that's what I meant with MAC address. And ARP-A gives you that information. So if I go here, I think it should be safe to do it. Maybe not. Let's see, ARP-A. So you see there are MAC addresses I got. This is what it is. I don't know what they are for, but because my system is, I think, connected already to a virtual box, basically, it will give something around that. So that's some extra information. Hopefully that helps. So this will show your source and destination MAC addresses from data link layer to the OSI layer. And these MAC addresses, because we are sending to from someone to someone, right? So both will have MAC addresses. And that's what it's talking about. If you look at Ethernet 2, this has 2 MAC addresses. One is Xerox 1, 000001000000. Other one is like something else, FE, FF, whatever, right? You can spoof these two technically. But yeah, that's what MAC address is. Source IP layer 3. And if you, yeah, I think this is good. This will show you the source and destination IPv4 addresses from the network layer of the OSI model. This is basically the MAC addresses the IP addresses like the server address. Like Google 8.8.8.8, that's their IP address. There are two, IPv4, IPv6. We usually just have IPv4 in our case. So source, if you see, right, and destination IP address, flag, offset, time to live, how much time it should be, right? Hops based on the hops, and total length, identification, blah blah blah. Protocol layer 4. This will show you details of protocol used, TCP or UDP. TCP is the reliable one, UDP is I think I have a good meme on this. TCP versus UDP meme. So this is one of my favorite memes about this. No, open image in new tab. So if you see, right, there is a baby, right? This is kind of your data. In TCP, you sender and receiver. For example, let's say if an email address is there, data is make sure like both are able to send properly and receive properly. Whereas UDP, for example, your WhatsApp call, your WhatsApp video and audio call are technically UDP because data is just thrown. And sometimes when you're, yeah, like yeet, exactly, right? So if you're actually doing a WhatsApp call, let's say UDP, because when I'm, let's say, talking to my mom in India, sometimes I miss some information. WhatsApp video, like the protocol, is not making sure I'm receiving all. It's just sending all that information, bombarding it. Whereas if I do an email or a text message, it makes sure I receive it. So that's kind of the difference between UDP and TCP. That memes are a great way to learn. I will say memes are a great way. So what is this? Packet loss. So yeah, a packet loss because TCP is making sure there is like a proper system, but UDP doesn't care. So there are a lot of packet loss in UDP. And that's what I think we with the Cisco one we can see if we want to try. So that's what layer 4 is. This will show how the details of the protocol used, UDP, TCP, and source and destination ports from transport layer of the OSI model. So interesting thing I will say, UDP and TCP both have their own benefits. For example, UDP you can do with the radio one. That's a UDP. They are just bombarding. They don't care if you're. They don't even know. The protocol doesn't care if you're receiving it, all of it. They are just bombarding everywhere. So depending on the situation, both are important. I will say, and that's why both are still in existence, right? Like I guess. So TCP here, this was a TCP one. HTTP is a TCP. There are certain protocols like HTTP is a TCP. Your email ones, SMTP is a TCP type, right? Protocol. So that's one. Port 80 is the source port. Basically, if I'm sending, uh, basically from, let's say I have a server, right? And this is me. This is me. I'm talking to a web server or Facebook, let's say Facebook's web server. Source port was from this source port 80. It has its own IPv4. And if you want to understand source ports, think about your laptop, right? It has so many USB ports, USB-C ports. That's the physical ports. Network ports, there are, I think, 6,600, 6,500 65,355, I think. 66. No, 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 no. Sorry. How many total ports are there? Sorry. Total ports. 65535. Okay. 65535 total ports. So in your computer or like your computer or your laptop has like 4 or 5, which are physical, right? These are technically network or logical if you think about it. 65,535. Certain ones, if you know, are reserved, like 22 is for SSH. That's why we connect that. And that's what 80, this one here for Facebook, this goody good guy. Let me clear everything here. I love that everything is like kind of, you can see now it goes. So yeah, so here port 80 because it's a HTTP server, HTTP, right? Not HTTPS. HTTP is on port 80 and I'm receiving it on 3371 here, right? If you see TCP, this source port is 80, destination port is 3371. There's a lot more information, but a lot of time you don't need it if you're not a super high network admin. Hopefully, this is a good info. You're learning something more. Protocol errors. This continuation of the fourth layer, and I should stop asking all the time. I guess that might be annoying. This continuation of the fourth layer shows specific segments for TCP that is needed to be reassembled. Frame 26, 27. So this is the one I was talking about, stimulus. The system needs to know, right, which information, like there is only like a limit, right? When you are sending package over, let's say international, there is a limit of how much weight you can imagine. Now, because there is a limit, you are sending two different ones. For example, if you are sending furniture, you are sending two different packets. That's how this works. And this one, if you see, packet 26 and packet 27. So that's what it means. It's all interesting. My thing is reminding myself to try not to learn everything. Yes, like you don't have to learn everything. Just learn the things that get the job done. Like learn the things that get the CTF done, and some extra information, fun ones, which are not hard to learn. And that's the right way, though. Actually, don't learn anything. That's how I think Twitch went. Like I watched just two videos by Ludwig. I just started streaming and I'm learning on the way, right? Like you mentioned a couple of things like badges. I had no idea what badges were. I had no idea subscriptions were. I'm learning on the way, I guess. And that's the right approach. I think with tech, so much things are there, so many things, like it's unbelievable and you can't learn all. For example, think about it. Like if you were using WhatsApp, start learning about the UDP protocol before making a WhatsApp call. Yeah, I saw so many videos of it. I loved it, man. Ludwig is such an interesting guy. Like, it's such a chill guy to watch, right? I love his videos. And I think Ludwig is one of the most smartest marketing genius when it comes to Twitch platform. He's the smartest of all of the people. He knows how to capture, create interesting things. Like him, and specifically, I will say Mr. Beast knows how to create some good stuff. Yeah, he knows very well. I think he knows more than anyone. Like even Kai Sinet, that guy's smart. I've been following him for years now. Mr. Beat also had a massive team. Yeah, yeah. It's crazy how big YouTube and Twitch and all these like mediums are. And like these started like YouTube started 20 years ago in 2005. Isn't it crazy? Like it's so interesting. Like it started 20 years ago and how big it is now. It's just Twitch, I think, started even less, and how big it is crazy. Okay, let's. Yeah, it's fun to log these things. It's like helps in, right, like keeping the focus on, but also like these information, these chats like help with that extra fun, keeping the dopamine going. I like that. I like this. I like this. Okay, let's. Yeah, I know. I know. This is good, but this is good. Both are good, I will say. So, application protocol. So let's get back to this. Application layer protocol, layer 5. This will show details specific to protocol used, such as HTTP, FTP, SMB for the application layer of the OSI model. So application layer OSI model, I think the OSI model, TCP model thing. So what they are talking about here, I think I will bring both so it's easy for people to understand. Application layer, this part of the model is where HTTP, FTP, all those videos you are seeing, all those happen. So that's what it's talking about, HTTP. And if we see here, you will get the information, a lot more information. When we go, let's say here, this up, HTTP one. HTTP 1, okay, you see this in Burp Suite all the time, right? So HTTP 1 point, there is 2 and HTTP 2 and HTTP 1.1. The URL, content type, text and HTML. There is multimedia when you are on YouTube or streaming, right? Character stack, UTF-8, you can see encoding, zip4, okay, and all the other information, goody good information. Page read, Google syndication, page ad, and this one is Google Ad Services. So that's extra information here. Not need to go that deep, I guess. Application data. This extension of the fifth layer can show the application specific data. So regarding this, this is about the same application, the HTTP, but what exactly was shown is here. Cursor point and all those. So basically the style of basically the CSS, the JavaScript, and this is the HTML. I want to actually look more into this. Can I look? Expand all. No. Apply filter, wiki protocol copy. Maybe I can copy value and see if I can get something out of it. So let's say if I'm in Office, document viewer sound, or I can just copy here maybe. No, only this much is copied. All good, but this is basically your whole page, what you see, like you see on TryHackMe and stuff. Okay. So now that you have understand what a general packet is composed of, let's look at various application protocols and their specific details. Use exercise pcap png file to answer the questions. View packet number 38 with the markup language. Which markup language is used under HTTP protocol? Oh, okay. That's nice. Let's see. So let's close this and 38 just before this. So I just double click to see what is going on here. Let me collapse all. So here's the markup language below HTTP. That's called XML, extensible markup language. We saw about XML EE, right? Entity extension, I think something like that. So extensible markup language. Markup, yeah. Let's go. What is the arrival date of the packet? Month, day, year. So time, date is here, right? Month is May 2004 and 13. That's a long time. Month is May, so I think 05 13 2004. Let's go. What is TTL value? So time to live. TTL, time to live. This, if I give you a quick idea of this, how this works is basically there's a packet, right? There is like a package. If you are sending to your friend, this is your package, a gift, sending to your friend, right? Um, what for how long the UPS company, let's say the friend address was wrong, and accidentally even you put your address as wrong, right? So for how long the UPS company should keep on trying for the package to live or it will be discarded. Or same with, like, let's say at the airport, you lost your luggage, it was sent back, then came forward, could not find its proper person, blah blah blah. For how long? Till it's like thrown away or put everything. Same idea with the packets, right? So how packets work is, like, say this is your packet, right, with all the extra information, and there are so many routers and networking servers, right? There is your own router. I'll say this router is your own router, right? Goes to the internet. In the internet, there are also like so many routers, servers, and all those, right? Boom. One, two, three, four, five. Your friend's router, I guess, and then his server. So time to live, let's say if you set up, time to live is basically number of hops, number of servers it has touched. So that would be like, again, then one. Let's say if there was one here. Let me draw this better. So here, there was one here, right? So 1, 2, 3, 4, 5, 6, 7. So first time when you were sending, you said, okay, 7 is needed. Your computer will say 7 TTL. It it is not like a hard coded value. It's like, it's basically first when you are making the handshake, that's when it is set up. But then it's kind of hard coded, I think. So you can see how many hops kind of is the time to live. That's what it says, big and broad. So hops to live, TTL. Where is it? Window size, internet protocol, time to live, 47. So kind of 47 hops. Let me smooth all the ads. So because we are almost there, right? Why to put ads? That's unnecessary. What is the TCP payload size? TCP payload size we saw in the TCP one. 6432. No, wait, hold up. Payload size. Oh, payload size. Sorry, not window size. Payload size 424. I like that number. 424. What is the E tag value? E tag. Do you know guys? Do you guys know what E tag is? I would love to hear an answer before I find it. What is the E tag? E tag. What is E tag? Entity tag is a unique identifier assigned by a web server to a specified version of a source, such as a fingerprint, as part of the HTTP header, or is part of the HTTP header. Dang, I never knew there was E tag value. Here we go. Copy value. The man. I'll just copy this part of it. Let's go, boy. Big W is in the chat, baby. I don't know why I made that sound. Sorry. I'm so sorry. This is what happens when you're Hebrew 5. You make stupid sounds like this. But yeah, that's, I guess, task 3 of the WireShark. Great. I love this already. And we have packet navigation coming. How to go to packets, different packets, how things are connected. This is good for like understanding what's going on with a particular thing, I believe. Then we have packet filtering, which is a very big one, and then conclusion. And once this is done, I think we can either, based on whatever you guys select, either we can go on packet operations or we can hit the networking module put in the introduction to go a bit more deep. So whichever you guys like, let me know. Again, thank you Stimulus for suggesting this one, a big one. So thank you so much, everyone, and yeah, that's all I have for you guys. And if you can stay, I'll just put the ad at the ending, right? And if you have any questions, feel free to reach out in the Discord. Thank you so much. Thank you so much, Stimulus. Thank you so much. Love you too. Amazing. Thank you so much. That's one man right there, man. That's my man. So yeah, I'll be starting this ad. Let me know if you have any questions. I will be here in Discord. You can reach out to me. I'm mostly available during day. I come out and hang out. If not, I'll see you tomorrow. Till then, oh, by the way, Stimulus, I saw the ending one. I think I want to show you this. It does goes, but it just kind of freezes at one point. It does like very slow, and it does come back. So I saw that. So thank you so much for mentioning that. So thank you so much. Have a great day. Please, if you are not sub, please watch the ad or just grab water. But till then, thank you so much. Have a great day, and I see you tomorrow. Let's go. Thank you.